Hello and welcome to part 100 and let me have a look. 84 of the game engine coding live stream, and we're still doing code maintenance. It's part 3 of code maintenance and we're looking at start the small pointer stuff. So let me open up our project. A couple of things that I want to sort out in here. I'll do it off the tutorial. I want to move some of this stuff, but like the projects YZ and some of this GitHub stuff outside of here, because I have finally upgraded my SSD. Now it's a 1TB instead of 120 gig Corsair Force GT one that I had, and so that's provided a lot of extra space. What I also plan on doing is replacing this with an SSD as well. I'm just using what's the tool called, AOME backup, and that worked really well. So I'll be doing that for locals at this day. For downloads, I mean, outside of some file transfers, it's really, I guess, not necessary at all. So what I'm going to, at least for now, leave this as regular, but there are a few things like this project that is still in here that I want to move over. So anything that we're running is moved over, but yeah, freed up enough space, so less than a terabyte used on here. I'm gonna get a 2TB SSD for this, probably the Samsung. This is the Samsung 870 Evo. I'll probably get the QVO for this one. Don't need it as fast as that, plus save a bit of money. That's the main reason. Okay, so let's open up our project, see what we get. Just bear with me a second. I'm going to, because I've got a new monitor. Obviously you guys won't be able to tell that I've got a new monitor, but I've got a new monitor. It's the Samsung CRG9 49-inch ultra wide, and I actually got that pretty cheap, £500, usually over £1,000, used locally, and like the condition almost like new to me for that. So that is great, and because it is literally in terms of physical space and resolution the same size as having two 27-inch native monitors, it means I can have this, which is right now in a 27-inch format for me, and with that resolution, and it also means I can do picture in picture. Put it on. I'll be able to put the comments on here. Okay, so I'm going to tilt the screen a bit more. Got some speakers there. Okie dokie, so now I'll tilt it back the way it was initially. So what I'm gonna do is say I'm looking with bandwidth, to be fair. Overall it seems to be okay. So I'll leave that 1991, that's the year of my birth. Okay, so what we'll have a look at, when we was getting an error when we was running last time, it's just going to be a short live stream, just about half an hour. Got a few things to do after this. Okay, so bunch of errors. I'm going to get the errors done in this one file, and that will make me very happy. Okay, so we're saying no operating function which takes a right hand operand of type sonar rectangle, and sonar, well, that's a shared pointer. No. And what if I Let me have a look at passing in shared pointers. Post it in Discord as well. No, actually these aren't shared pointers, aren't they? They're on the unique pointers. Shouldn't I do it as a unique one, to be fair? Why don't I do this as a unique? Probably produce at least one more error or a sign in it. Okay, so there's a bunch of problems right now. So can I just do std make unique and rectangle would that actually work? Change it to label. Okay, so how do I return it now? Have a look at return unique pointer. Let me try that. give it a run, see what happens. See if any errors where we're using the return value, could that be causing some errors? I feel that maybe. It's all in here so far. That's moaning. Get method. to do some more research into this pointer stuff.
So this 0 can be assigned is equal to the unique pointer, because you're just passing the address of this shared pointer object, whereas you should we will do this as smart pointer get x, and yes, this operator is overloaded in this class, and shared pointer is a class, class template. Okay, now if I will compile, see, I have not written delete and it is printing this, and at last when I'm hitting this bracket, which is saying that the scope of this guy is over, at that time it is calling destructor automatically. So that's what was happening in unique pointer also, right? But here is the magic. We can use this sp get count, use count, and it will tell you how many places this is used. So just to differentiate, I will make this one as 100 and save this and compile this and execute this. See, this is printing 100 because we are passing 100, and now it is saying that the use count is 1. Let's
give that a run, see if that fixes any issues.
increment the so this is we cannot increment the rep
a raw pointer. If you saw, that's a function template where you have to specify what it is that you're making. What are you keep out? I probably have some. And there is no way. Or
in this script, you can repeat the code in doublets to just put a sequence to the execution. So we will function goes there, we call the constructor, we call the destructor, and exit main. So it's pretty much simple as of now. Okay, that this calls this, and that's all. But how does we know what is shared pointer? So the things will start to change if we return shared pointer from here and take the shared pointer from in here. So if I take a shared pointer of same class, let's say spirit, calling the function. So let's see, I run the program. Now the sequence has changed. You can see intermain. Now we are calling the function. It creates the shared pointer, and you can see the constructor gets called. Now it comes back. It says the exit main, and then the destructor gets called. So basically, when it goes out of the scope, the destructor doesn't get called. That means this object is not deleted. Why? Because shared pointer is capable of two things. One is the transfer of ownership as well as multiple ownership. That's why the shared name comes from. Shared pointer means multiple ownership of a same object. So as of now, it's transferring the ownership from here to here. So this ownership is taken by this shared pointer spirit, and when it goes out of the scope, it deletes it. And this will be more clear when we, let's say, we are not taking it. So we are anyway returning shared pointer, but we are not taking it back over here. We run it. Let's see what happens. Now you see the sequence has changed. In the function caller, the constructor get called, but before this return, after this return, before coming back here, the destructor gets called. Why? It's the beauty of shared pointer, because here it knows that there is no other shared pointer to take it. Though I am returning it from a function, but there is no other shared pointer which is taking the ownership, so it has to delete it. Okay. The thing shared pointer do with this is by the help of this reference count, shared pointer maintains a reference count. Okay, and things will be more.
Hey, what's up, guys? My name is owns that shader, right? Because if it doesn't electric stove for some reason, then same thing here. You wouldn't just write an engine that uses a single thread, because that's somewhat silly. So because we use multiple threads in our engine, that render command queue that we've kind of deferred, that's all the stuff that our renderer has to do. Consider this, we've changed our level, right? Well, we've released an object from memory because the application, the performance overhead is so negligible from using a shared pointer over a unique pointer. In certain situations, 100%, you might want to use a unique pointer, but to be honest, I think from experience, and I'm just kind of thinking back in my head now, most of the times where that has been the case, I've just used a raw pointer. Because, right? I don't think, if I'm dealing with that kind of stuff where performance is such an issue, I'll usually use raw pointers. Not because unique pointers are slow, of course they're not, they have zero overhead. It's because that kind of code base that requires that is most likely going to benefit from a raw pointer. You could still enclose it in, you could still encapsulate it inside a unique pointer if you wanted to, but from experience, probably not something that I've actually done. The point is that unique pointers are great and you might want to use them, but in pretty much all cases, especially right now when you're not just bottlenecked by the fact that you're 90% of your thread time is because shared pointers incrementing and decrementing references. That's not the case. So every single asset in the engine that gets submitted to the render thread especially should be a shared pointer, and that's kind of what we're dealing with. Now, before we get into the code and we take a look at this, because what I want to do is change the way that we actually present shared pointers, like just change the way they look, and you'll see what I mean in a minute. Before we get into that, I just want to quickly mention, shared pointers do have overhead, right? Now, I've just mentioned that it's negligible, and I'm probably right, but in some certain situations, maybe we decide that we don't want a shared pointer necessarily, right? Because shared pointers do a few things. First of all, they're not an intrusive ref count object, meaning the reference count is not stored as part of the actual object that you've allocated. It's stored in a separate control block, which in most cases is going to be in line with your object. So that somewhat negates that issue. The other issue that we could potentially face if we're nitpicking is thread safety. So shared pointers are thread safe, meaning that the way that they achieve that thread safety specifically is they use an atomic increment and an atomic decrement. I never say that word. Anyway, they decrement, it's gotta be decrement. They decrement and increment the pointers, the reference count atomically, which is fantastic for thread safety, means we'll never get errors really, but that obviously has to lock everything up and do that atomic increment, decrement. That stuff takes time, could potentially add a little bit of overhead. Now, look, I'm not going to argue with you. I'm not one of those just crazy people who will absolutely fight over such a small, in reality, such a small kind of hitch in performance, right? Especially because there's so many other things we could optimize. But since it could be a problem, and since we might want to say, we don't need thread safety, we want to just run fast. Not that we won't run fast with this, but, just bear with me. We might want to change it into our own kind of ref count object, right? Which would, for all intents and purposes, probably be a shared pointer class. Like it'd probably be exactly the same, except it would do a normal increment decrement instead of an atomic one. Because of that, we
Sci-Fi
might
No
want to
says
change
hi.
in the future.
Hello, hello,
For whatever
hello.
reason, shared
I'll be
pointers might
wrapping
not be
up in a
something
few
that stick with
minutes.
forever. So because of that, that's going to be a very difficult change, because we'll have to find and replace all shared pointers and replace them with something else. Maybe in some cases we actually do want to use shared pointers though, right? So what we need right now is, well, there's two issues. There's that, which I've just mentioned, but there's also the fact that std shared pointer everywhere kind of looks a bit ugly. No, it's not the worst thing in the world, but it kind of looks ugly.
I agree.
So what we're going to do is we're going to create our own little type that is essentially a shared, it's going to be a shared pointer right now. In the future, it could blossom into its own type, where it's like, you know, actually a class and everything. But for right now, we're just going to change it so that it's going to be our own thing, and that's going to it's going to be called a ref. So it's going to be called a Hazel ref, okay? And what we'll do is for the unique pointers, we'll also create a Hazel scope, right? So we have a scope and we have a ref. So the scoped kind of pointer is going to be our Hazel scope thing, and then our ref is going to be a shared pointer. So unique pointer scope, because that's what it is, it's just a scope. And our reference we're going to call ref. So let's take a look at what that's going to look like and see if it makes our code base look nicer. Alright, so the first thing that we're going to do is go to our core.h file, which contains pretty much all of the core stuff. And I'm going to add a namespace called Hazel. Right, nothing too special there. And then what we're going to do is create essentially a type def, so we're going to use using for our two different types. So scope being a scoped pointer, right? So this will be a unique pointer. And then we're also going to create ref for our ref counted object, which is a shared pointer. So because of course we want this to work with templates, that's why we're actually using, apart from the fact that using is the thing to use these days, it also enables us to actually define this as a template. So we have a template, type name T, and then this just goes here. And now what we can actually do is use scope with a type when we actually make it, whenever we end up using it. So this is obviously vital, because otherwise this wouldn't really work. We'd have to like, and I mean, that's the other thing, like you could definitely do stuff like, let's just say we had a shader class, right? Instead of writing ref shader, which you currently have to do, and this is as opposed to, std shared pointer. So what is basically done is enabled us to change this code into just simply writing ref shader, and if we're outside of the Hazel namespace, we'll have to do that. Kind of shows you very easily that it's a Hazel ref, or for a unique pointer, we would do scope, right? But apart from doing that, you could also create your own using, where basically shader ref is a new type that is that, right? And if you do that a lot, maybe that might make sense. But that's not something that we particularly care about. It's another common way to do this, where basically you just define a new type, at the end of your shader class, like literally in shader.h, we could potentially just add like a using shader ref equals, either std shared pointer shader or whatever, or you could just simply, in this case, just write ref shader. But I think ref shader is not too difficult to write, and I don't like creating a billion different types. So because of that, you can basically just stick with this. Now, this is all the code that we need, right? It's really simple. What it means in the future is we can simply just change this scope thing, to be an actual template. So type name, what am I doing? Template, type name T, and then, class scope or whatever. And then we can just make a class out of it if we want to, and we don't need to change anything in it.
I'm going to end the video here. I'll continue watching this next time, and I'll continue doing this, but I haven't really quite figured out this issue yet, but I will. Let me commit where I've got, and then I'll probably move the project over on the different hard drive anyway. Scratching my head with these shared smart pointers. Okay, so I'll commit this. Yeah, I'm going to wrap up now, and I'll see everyone tomorrow for another live.